Kalangasan, and I'm here to report about partitioning. It's about partitioning in parallel computing. So what is partitioning? So one of the first steps in designing a parallel program is to break the problem into discrete chunks of work that can be distributed to multiple tasks. This is also known as decomposition. In computers, partitioning is the logical separation of hard disk. Users usually make this to allow them to run multiple operating systems on the same hard disk, or to give the appearance of having multiple hard drives. A partition is the process of separating something into parts. Partitioning a hard drive is an example of how to do this. Partitions are the act of dividing room into separate areas. Partitions are the walls that separate rooms. This wall is an example of partition when it comes to walls. In short, so partitioning is the division of the task of what a computer has to do. Which drive is the first partition? Under Microsoft Windows computers, by default, the first drive contains the first partition in the C drive. So example, if you wanna have a clear partition program and you wanna see it clearly, so you can try on your Windows computer. And how does a partition look like? So the best way to see a partition looks like is to open the disk management tool and press the window key, then type the disk management and then press enter. So after you do that, you can see on the screen on my example, you would know the parts of your computer. So as you can see, there is the primary disk, primary drive. There are partitions in different kind of tasks. On that kind of task, it was look like a partition. There are two basic ways to partition computational work among parallel computing. So the first was domain decomposition, and the second is a functional decomposition. So I will report about domain decomposition. So what is domain decomposition? So the data associated with a problem is decomposed. In short, it was divided in different tasks. Each parallel task then works on a portion of the data. The main idea is to divide the global domain into multiple subdomains, then solve the governing differential equations into several or all of them at the same time. So problems like data communication and storage capacity develop as a result of this, and they frequently represent the limit of parallel computation. As you can see in the image below, partition is each task handles a portion of each dataset. Example was the problem dataset, and it was tasked by 0 to 3 tasks. So task 1, task 2, task 3, and task 4. And all that tasks was called a partition and decomposed by each data. Next, so the major processing parts of partitioning. So there are different kinds of parts of partitioning. First, the computer nodes. Second was the domains, and the third was the subdomain. So what are the computer nodes? It was the workload of each job is distributed across several processors or one or more computers. Example, as a programmer, computer nodes are the datasets which you can transfer in other computer nodes. So what are the example of computer nodes? It may be your gadgets and cell phones, your tablets, and etc. So the domains are the computational work among multiple processors. So these are the parts of your computer that you want to send to another computer node. So subdomains are the subdomains are the part of the domain that comes before the main domain name and domain extension. So subdomains, as you can see in the image before, subdomains are the tasks that use to give to the other computer nodes. Next. So as you can see in the figure A, these are the domain, and the figure B are the subdomains. Domain A is a whole part, while the domain B divides into 9 parts. It means there are different kinds of tasks in each node. Every node have different tasks that will transfer into another processors. Node 1 to node 2, node 3, node 4, node 5 until node 9 have different tasks and gives another computer nodes. If there is a situational part of it because they have different tasks that may transfer in the computer nodes. So in short, the subdomains can be distributed across the available computer nodes. So every color can be handled in a parallel or the node's computer subdomain solutions for the current color at the same time and proceed to the next color. In particular area, if you're gonna work in a company, I am the manager and I will transfer the task to different kind of persons, just like the computer nodes and the domain decomposition works. I hope you have learned something from me. Thank you.